yeah, it might be good to throw in what a definition of legacy system is. It's basically like a large-ish system that has been like maintained for a while. I'm going to go into this a bit deeper because there are multiple definitions, of course, of what a legacy system is. But yeah, a large, old, maybe some guy that built it in the first place is leaving or has already left, and you're left maintaining it. So it seems that some of us have played with legacy systems, or I don't know if play is the right word for a legacy system. And the next question is, where did you have the most legacy? So as I see it, like, did you have the most legacy in the front end, like the JavaScript and HTML, CSS? Or did you have the most problems in the back end, like the backend system itself? Or did you have problems with the integration between the backend and front end? So like an example of a backend front end legacy system, so to speak, could be a large system that renders all of the HTML on the server. So like the entire thing is coupled, and you're trying to decouple the things, and that's where the legacy is. So it seems to be a bit mixed, like very freaking mixed. All right. So how do you battle legacy? So rewrite, or do you add more code to it to try to battle it? Do you try to refactor what you got without doing sort of any major overhauls? Or basically you try to live what you got? And plus points to everyone that says I don't. Like, no, I'm kidding. Yeah, so the classic options is basically these four in my point of view. I would say that as engineers or as developers, as programmers, we're heavily biased towards the very left, which is rewrite, because it means that you don't have to deal with someone else's mess, you have to deal with your own mess. But the question is really like, is that going to be simpler? And the question is not if it's going to be more fun for you, but if it's going to be simpler for the company and if it's going to bring your actual users value. And I think like Philip's case is really cool, since both of you guys are sort of so close to the customers, and sort of the engineering and sort of the customer-facing things is seen as one thing. So in that regard, like the rewrite will obviously sort of be in like, are we going to bring users new value? And I think that's a question that we're biased towards not asking ourselves, because we want to rewrite. But sometimes a rewrite is the right thing, definitely. All right, so the agenda is basically I'm going to talk for a while and go through this. And please, 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 please interrupt me. Like, I'm dying to hear about your legacy system sort of experiences and what you have done. So yeah, please, Marco. Perfect. So that's what I'm going for. Like, raise your hand, bother me, stop me, give your own opinion or your own example, or disagree with me. Like, please, 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 please. And the next part, I'm going to show, because we're currently at TrialB working towards separating our backend and frontend a bit, and seeing that as a way of doing some backend refactorings, as well as sort of redoing things in the UI without doing like, okay, stop the world, we're going to rewrite this for a couple of months and nothing's going to happen. So how do you sort of like, in a live system, in a live project or application that users are actively using, how do you migrate a system to be sort of more sane than it was before? And some definitions of legacy systems are basically like, yeah, that's not a legacy system because it's used, while others have other definitions. So there will be code later on, and the code will be geared towards the sort of front and back end complexity that sort of grows together. Yeah, so disclaimer, this is my own personal opinions to some extent, and not the opinions of my employer. And your mileage will, I should have said will, vary a lot. Because when it comes to legacy systems, our systems look vastly different. So like our system at TrialB are battling different problems than, for example, Unified Remote. And so sort of taking some guy that wrote a blog post or whatever, and saying like, this is the thing for all legacy systems, please don't. Well, that's my point of view. So I'm Jacob Burenstam. I like to tinker with open source as much as I can, if I can. I love useless code. So if anybody has done some useless code, please come up and talk to me about what you did with your useless code, like fun hacks or whatever it might be. Um, and I work at Triley as a full stack developer. Our backends are mainly in Ruby, using the Ruby on Rails framework. How many of you have played with or at least touched Ruby on Rails? So you have somewhat an understanding what it is. It's basically like an MVC framework that you can use. It's written in Ruby, and it's become quite popular over the years. And our system that which is built in Ruby and Rails was started. Let's see if I can remember, like 2011, I think. So the application has been in active development for over 4 years. And during that time, we have done some very heavy prototyping. Because a lot of us at the company didn't have a medical background, so we didn't really we didn't know upfront of what the customers needed, or what they needed. And the other thing was the customers themselves didn't. I should have added that. One of my favorite quotes is from Henry Ford. And he said when he sort of like, if I were to ask customers what they wanted, they would have told me faster horses and not the car. And that's basically our case with our customers. Like if we ask them what they want, they said like, yeah, we want to be able to write on paper faster, or give the doctors a pen that makes them available to sort of write faster or something like that. So they're living very much in like last decade or 2 decades ago. So legacy code, and I think like, yeah, first of all, it starts up really well, it starts going bad, you start smoking, and then pills, and then sort of at some point you start feeling like this is it. So this is, I think, what many people have experienced with legacy code. I was sure as hell tinkered with open source projects that has definitely this kind of curve for sure. So like, yeah, you sort of feel like, yeah, it's sort of okay, and then you feel like, oh, I'm on the right way, and then things start going badly, bugs are introduced, and then yeah, the rest is history. So what's the definition? There are many definitions, as with anything in computer science and as with anything in English or any language for that matter. People are going to have opinions about words, so please don't take my word or for what a legacy system might be. A couple of sort of standard definitions is, the top one is actually sort of brought from Wikipedia. So it's code for outdated, obsolete systems. So basically maybe like imagine the Linux kernel, like supporting things for really old, basically obsolete systems that are still hanging around somewhere. And you might need to keep them available. It can not be sort of from a user's product standpoint. It can be for like compatibility reasons. It can be for legal reasons. And it can also be for, yeah, service level agreements and others. And some others say basically like code written by another person that don't maintain it anymore. So I think that's a pretty good definition. Of what it is. And then Michael Feathers, which is pretty prominent in this area, he basically said it's code without tests. Like that's his definition. Anything without test is legacy, which is a pretty harsh definition, I think. Maybe a bit too harsh, but there is some truth in it for sure. So the internet has something to say about legacy code system. So I searched Google. This is what I got, like code you didn't write this morning. That's a quite harsh definition as well. I think this is true to some extent. This is another one, like fixing a bug in in legacy systems. When you fix a bug, you create 30 more. Yeah, you simply do not refactor legacy code. I think all of us have been through this step at some point. All of us recognize whatever this is, even though I have no idea what I'm looking at, except spaghetti. And I think all of us have seen that.
What does refactor mean?
What refactor means? Wow, that's a oof, oof. I would say like I wouldn't be the one to ask for a clear, nice sort of definition. And I think some people have been in this situation as well, like approaching legacy code, like you strap up, put your helmet on, and sort of buckle up. And I think all of us should be really afraid of this guy during a rewrite, like trying to be too clever, writing like too large tools to automate things or whatever. So like, yeah, please test the things you're doing or ideas you're having when refactoring or when trying to battle legacy code. Like, don't go off on weird sort of huge ideas of reinventing something cool. That's not when you should innovate. When you deal with legacy code, like you can innovate, but like be careful about it. Don't sort of add new things you are not familiar with yet, in my point of view, in that stage, because you're basically doing two things at once. But to some extent, you will need to, so to speak, invent things or build new things in order to get away from what you have. So it's as anything, it's a trade-off. So from Wikipedia, I think I actually was quite surprised that I found this on Wikipedia, but I think this is really good. Like for the second paragraph, they start the paragraph with a large part of the task a software engineer is to continually alter the code to prevent this, and this is in this case is legacy code. And I really found it interesting that it was a large part, because in this room, I think we're sort of more of us, and if you take like the average developer, I think more of us here in this room are in startups and in smaller, younger companies than others in general. And especially if you work in really large corporations, that's going to be a huge part of your work. So I think that's a really good and a really sort of thing you should remind yourself of, and I will try to remind myself of this going forward, even though a lot of the things I'm building now isn't legacy code yet. So yeah, yet again, there are many ways to battle legacy code. Please don't believe anyone that say that they have a silver bullet, as with anything. Be very, 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 very pragmatic. Like that should be the thing you're thinking about. Keep it simple. Try to make the simplest, dumbest solution to a problem that you can have. And I think this is especially true. I think this is true for all software development, but especially when dealing with legacy code. That's even more important in that case than in other cases, because the problem is, like, if you change things in legacy codes, you usually can affect other parts of the system, and you don't want a case where you sort of ask yourself, where is the problem? The new code, old code, and you don't know, and you have to sort of go back and forward a bunch of times to figure out where the actual problem was. I think in what you should do with any code you write, and especially in legacy code, and especially if you're doing sort of like architectural changes that you want to introduce to the sort of like larger product or system, it's to be like really oh sorry, I basically lost track there. To be really sort of, the things you're afraid of might not be perfect or work. Like try it out the first as soon as possible. As soon as the sort of like devil's advocate far back in your head say like, this might be tricky, test that out first. Don't always say like, I'm going to deal with that later. Like that's a good thing, deferring decisions, but make sure that your decisions that you've already made are correct. That's a really important thing, and I think that really touches on that. So back to Michael Feathers again. He has a bunch of points here for like how to do it. Basically, like what he tries to do is find places where it's nice to refactor. I don't think like we should go through this in depth, but basically it's like find suitable places for refactorings. And I would also like to say sort of like on a larger sort of scale, like look at slices of the system that you can extract. Like, for example, if you're doing some very, I don't know, emailing and you're writing your email thing by yourself, that might be something that you should extract in that case and have it as a separate service or something like that. Or just use a service for that matter. Just do a REST API call and you'll be done. So that's also a part of refactoring legacy, I think. Like look out for places where you can replace your legacy code with services, both internal services that you build yourself or external ones. And like, and also sort of remind yourself about the fact that $100 a month isn't much. If you spend as an engineer like 1 hour a month doing the same thing, you're saving your company money. So, I just want to give a shout out to this talk. I love this talk. I don't think that we should design systems exactly the same way he sort of says or experiments with in this talk, but I found it as a really interesting sort of high level idea of how to approach things. And he basically talks about the functional core and the operative shell. So you have a bunch of like pure functions. That is a huge thing in JavaScript nowadays. At the core of your product, and then you write sort of ugly I/O handlers or whatever, like dealing with the messy world on top. And the core is completely pure. Like you won't need to be like all of those single methods will be really simple, and then you can write your ugly code at the edge of the system rather than at the core of the system. Because that's one of the things that I've really sort of, when I watched this talk and really went back to the code that I've written and sort of went through it, I could really see that I was mixing and matching these things. So I had domain logic and like some functional logic transforming some data basically in the same class. So, you guys remember this from the first slide? I said I loved useless code. Here's the proof of the fact. The previous slide actually runs. It's executable code. If you download and clone my repo and run this very code, it will actually print the slides in your terminal. and it wouldn't have done that before 7 today. So yeah, useless code is fun. Please do it. So, as I mentioned, we were battling currently with one of our systems with sort of extracting the backend that now also renders the HTML, to extract that to a different layer without doing a overhaul of the entire application, sort of like making the backend speak only JSON and making a frontend in Pro JavaScript. So there are a couple of ways of how to approach this. Like either you build some sort of own integration, so to speak, which I will show you what we have done so far, or some of the things that we've done so far. And there are a bunch of existing libraries, how to integrate like React or whatever it might be. In our case, we're using React, so that's what we've been looking for. And there are tools in numerous languages. I did a quick Google, like this is the 5 first results I basically got. There are React Python, Python React to make you really confused. And there's a package for Meteor, which also is a JavaScript project or framework. There are a couple of examples for Ruby, and there are one for PHP, there are many for PHP, but I just wanted to sort of get to the point that there are integrations that you can use. So with that said, I think it's time for us to look at some code. So I wanted to do this in a real application, so to speak. This application is ridiculously small. It does basically nothing. It's not a legacy project by any means, but I wanted it to integrate our test solutions or like sort of approaches to something that was a bit more real than Hello World. So this project actually has some code in it. It's very, very small. It's our simple like deploy tracker. You send it like I deployed this version to this server and it will track it for you. And we've used 2 different approaches, or we've tested 2 different approaches, or I have tested a couple of approaches. So us being Ruby on Rails sort of, we're using Ruby on Rails in one of our products. And there are a couple of integrations with React libraries that we have. And one of them is React on Rails. And this is not Rails specific, like at all. Like all of these concepts are translatable to whatever language you might be using, if it's PHP or Perl or Turbo Pascal for that matter. And basically I think I should back up here a bit. So what our problem is that when you go to, let's say, just for an example, to our website, this HTML blob is rendered by our server. Like it returns the HTML like you would 15 years ago, and that's it. And that will mean that all of the logic rendering this will also be living in the same code base as everything else. like literally everything else. And that can be a problem. That is especially a problem. I'm gonna close this because we're still. And especially a problem because you'll need people in order to work on our product currently. Like you're going to see and read a bunch of Ruby. Not everyone knows Ruby, especially front-end developers don't usually know Ruby. And quite a few front-end developers know HTML and CSS, maybe a bit of JavaScript, like very, very little, but that's basically it. We can't have them in our product. We can't have them update our landing page currently, which feels a bit weird since that's basically just static HTML. And also we have the problem of when we have Ruby developers, we basically need them to be able to understand sort of the front-end side of things as well, and not only be Ruby developers. And our problem is currently like, okay, so we have a huge system. It's rendering HTML on the back end. We have a few JSON API endpoints, like most systems nowadays, but it's not an API. Like our service is currently not serving everything through an API. And it basically leaves us with either we rewrite the entire backend, or not rewrite, but sort of make each endpoint serve a JSON instead, and then we basically do a completely new front-end project that will then consume that API. And that might be a very, very sensible solution for very, very many products and code bases out there. But for us, that would pose a problem. We have quite a few customers, and our customers aren't tech savvy at all. Like there are 65-year-old doctors that basically heard of the internet yesterday. We actually asked a customer that sort of said like this page didn't work, and that was his bug report. So we asked him, so what browser are you using? Like basically, who are you? And so forth. And to the question, what browser are you using? He answered Telia, Outlook, and Windows XP. So we said immediately, like, well, he's obviously using Internet Explorer. So that's our customer sort of. And we had a bug for a while that the Bootstrap grid broke on IE8, and we actually have quite a few IE8 users at some clinics. And the entire grid system like broke, and it took us months to get we didn't get the bug report. A colleague of us went to the clinic to get some feedback, like in general, and she saw their landing page when they logged in, and she's like, "Oh shit, something's wrong. What's going on here?" And they were sort of surprised, like, "What's wrong? I don't get it. Like it's as it always has been since we used it." So that's our customers. Like they were using a phone layout on a monitor for 24 inches and didn't realize the thing was broken. So that poses some pretty strange sort of requirements on how our product works and looks. So like UI changes is quite straightforward usually. Like if you move a button from one place to another, users don't usually trip up that much. But in our case, that's the end of the world, basically, sometimes. So that's a huge problem for us. So we really need to be able to like gradually introduce these things, and we need to introduce them in a somewhat backwards compatible way. And when I say backwards compatible, it's not necessarily like from an API standpoint, but more from like the user doesn't notice that something changed, basically. So that's sort of let us out pretty quickly from like, okay, a complete rewrite is going to be really hard. It's going to be really difficult having all of these users and doing one single sweeping upgrade and having everybody actually be able to use the system the day after. And also, like, we have some trainings basically with our customers on how to use certain parts of our system since they're not very used to the internet itself. Like, single click, double click is still a mystery to them. that's the thing. So back to the code then. So one example is that you can, most of these libraries that I showed you before for PHP and others are basically like they let you serialize an object in the language, so in PHP, Ruby, Perl, whatever, and basically pass that to React as props. And that's, well, good-ish. to me, you lose a lot of the real benefits of having something client-side, because you're basically doing exactly the same thing as you did a minute ago. But it can be, for some products, a sensible way forward, because it gives you, in code at least, somewhat of a middle ground to work yourself towards. Like, you can rewrite just the client without touching the backend whatsoever, and the only thing you need to do with your sort of view object is serialize that to JSON and give that to the React app. And that's it. Like, it's really simple, and that could be really, really good. On the other hand, you lose the sort of real benefit of doing client-side JavaScript, where you basically don't need full page reloads. So you obviously lose that. But it's a really simple way of gradually moving in the right direction. And it also, if you have, like, I don't know, weird logic in your view object that doesn't really belong there, it will be very noticeable when you try to serialize that object to JSON. It will basically tell you, no, I can't serialize a function in PHP to JSON, which is a good thing. And many of these libraries, they try to give you various like helpers for this. So maybe I should put this up. So, and the PHP integration and one of the Python ones was basically this exact API. Like, you had literally the same name for the function in most libraries. It was React component. Oh, sorry. Oops, wrong way. So basically you have a, whoops, come on. You have a helper, just a regular method. And like the things on the sides are basically like, yeah, in output whatever to the HTML DOM. So React component, the name of the component, and some props. And this thing is, in our case, some view object or a hash that can be serialized to JSON. And that will just be passed just down to the React component. So when in React, you will use everything just as you used to. And then most libraries also have some sort of pre-rendering logic where you can have some JavaScript runtime on the server and so forth. So the benefit of going this route and using tools is that, like, if you're new to things, you sort of have a set of rules that is quite well defined. And even though I've played with React a bit for a few months, or like a couple of months, and even though I've been using Rails for years, like integrating this particular library, and I've tried another one as well, is not always straightforward. It really depends on your setup, what you're doing, because like a lot of these libraries has a ton of opinions of how you should do things. And depending on how you do things and how you want to do things, that might be a good or bad thing. So in our case, we ended up actually not doing a sort of framework, existing framework. So what I like to show you is the integration that we did. And it's complete. This integration is, you basically build a separate node project. You spin up a new project. You do, was it npm new? I'm that bad at npm. Init, sorry about that. So you basically do that, and you get your new project, and you can work with that project in isolation is our goal, and we actually already achieved it. So you can work in that application completely in isolation. The backend app is not a thing. You don't have to be bothered with it. The only thing you need to be bothered with is the props that you pass down, which is something you need to be bothered with anyway. And it runs outside of the scope of your app. And from a legacy system standpoint, I'm feeling sort of fuzzy inside when I hear that. Like, you have your legacy system, you can build something on top of it that is not a part of the legacy system. I think that sounds really, really great. And after sort of that goal that we had, we sort of asked ourselves, so how do we integrate these things nicely? So in Node, you have like hot module reloading, perhaps, so for updating code without refreshing. You have a ton of things that are available to you. But within your sort of server-rendered app, or if it's Laravel in PHP, or Rails in Ruby, or I don't know, Meteor or whatever, like that's its own thing. That they haven't thought about the integration with Webpack or Browserify or whatever you might be using on the client side. So this integration doesn't care about that. What we basically have done is in our legacy app, so to speak, we have a method that spits out HTML. And that method is really simple. It can do basically two things. One thing is to integrate or sort of add a path to a JavaScript file. The other thing is call a named method. So what we do is that we want our legacy code to be using multiple React apps. Not one, but multiple ones. So like basically our analytics system can be its own React app. And our something else system can be its own React app. And you don't have to be bothered with either of them. And to share, we can share sort of some core modules between them, obviously, using NPM. And what that allows us to do is keep things in really small isolations, and gradually update, and that in general makes things really easy, while keeping the integration in the legacy app. Basically, the implementation is 60, 70 lines of code. And it's stupid code. It's like getters and setters, basically. So what we do, if you can render your React app in two modes. One of the modes is production mode. The other one is development mode. And the only difference is that either you fetch a static JavaScript file from a path, like you would in any project, or if it's in development mode, you fetch that JavaScript file from a running node server. That's basically it. So, yeah, here's some Ruby code. I'm sorry about that. So basically, we have this. We have a path, and the path is either it grabs the port and host, so you can have you can shuffle things around if you want to. So either the HTML, I think it's better if I just sort of type it out. Either the HTML would basically be like script, source, and either it will be localhost something like my app.js, or that will be some local path that is sort of bundled within the project. The thing that makes this really cool is deployment. Our deployment process for our legacy app doesn't change at all. Like, we don't touch the legacy app. We don't have to deal with it. We don't have to deal with bundling the React project, or Webpack is not a thing in our legacy app at all. Like, it doesn't have any clue about what React is or what anything is. The only thing that it knows how to do is output that kind of file and sort of grab an asset, which is like pretty straightforward in almost all web frameworks. And the other thing, it puts out a script tag that basically looks like widget name, and then we have said start is the function, and it takes basically an ID to the or an element. So you do document get element by ID basically. So that's the total amount of code you're going to put in your legacy system. It's going to render basically these two lines. And the only thing that it needs to do is either not prepend that or have that. That's basically the change. This stays exactly the same. No change whatsoever, which is pretty cool and extremely simple. So in the Node app, you're just dealing with that, and the other thing, you just deal with the legacy code. So in our case, what we could do is we could outsource, in theory, we could just outsource the React app, like the Node thing. We could get a couple of guys, ask them, like, this is the API calls or like the data that you're gonna get, and this is how we would like it to look, and they can build it. And they won't need access to a legacy code base. They won't need access to anything. So that's pretty nice. And on the Node side, that's it. Like, you just do your Node project as you would ever do, like any other project, and that's it. And actually, just this morning, I managed to get hot module reloading working even within the legacy app. And basically, the only thing you need to do is add a proxy. Sorry, I'm no use. But this is basically the code. It's not complicated, as you can see. You basically proxy all requests that the rule here, the magic rule, is basically coded on this line. Like, if the path of the request includes .hot update dot, which is basically Webpack's pattern, it will proxy that to the node server that is running, and you will have hot module reloading within your legacy app without the legacy app basically knowing about it. So the cool thing and nice thing about this approach in general for us is that it gradually lets us to roll out things without changing our deployment process, without having our legacy app knowing basically anything new. Like it knows how to render HTML, it knows those kind of things. And this is just convenience, like this is just an extra. Like we didn't really need this, but it just happened to be simple to do, so we did it. So I would say like what I really like about this solution is the simplicity of it. Like we don't depend on an open source project. Like I can't for the life of me see why I would use any other way. Like I can't see any problem, and I'd love someone to challenge me on this. I don't see any problem doing it this way than doing it another way. And if you want to have it bundled within your app, that's fine too. Like you can have your Node app within it, but they don't have to sort of in code know about each other. It's just a matter of like how you structure your folders, basically. It's a bit small here, but as you can see in this folder structure, we basically have a vendors folder, an assets JavaScript, and there's a minified JavaScript file. Like this is the distribution of it. So we include this file in production, and that's it. And the native app looks like this. So we have a webpack config, like very, very standard webpack config with hot module reloading configured and like, yeah, straightforward things. And this is a React app that uses Redux. How many of you have heard of Redux? Okay, quite a few of you. So Redux is Flux, basically, but a library built around that concept. So we have, in this case, I have the simplest, like, okay, so as I said, this is a deploy tracker. It tracks our deploys. So this is just a deploys component, and this basically just fetched the deploys from the server, and this actually happens to be a JSON call in this case, and yeah, so this is just regular React code in that regard, and this could be in any language or any framework. This doesn't have to be React or Redux. You can use Angular, I guess, like Backbone, whatever. It doesn't care. The only thing that this solution cares about is basically like at the end of the day, you have a JavaScript file that it can serve on production from the same domain, because that makes our session handling ridiculously easy. We don't have to develop in our legacy app a notion of client-side authentication in that regard. We just use plain old cookies as if it was just a regular jQuery thing or whatever. So for example, in this case, like, and the integration code for our legacy app is as much as this is, or as little, it's 60 lines of code. That's the sum of all code that went into our JavaScript, into integrating this solution. Like 60 lines of code in a legacy app, that's it. And it does, yeah, it even does hot module reloading and all of that with those 60 lines. So it's it's simple in that way. Yeah, GitHub had a really cool approach. I think it was GitHub at least, when they upgraded, because they were using a forked version of Rails, and they wanted to upgrade to the new version of Rails. And they were struggling because they have done quite a few changes to the Rails framework itself. And what they basically ended up doing was they ran their upgraded fork, or sort of their branch, running the new version of Rails. And they actually deployed that to production. But it wasn't real production. But what they did was, I thought it was pretty clever actually. It was they proxied a smaller number of requests from their real load. So they sent this sort of shadow server, I think they used the name for it. So this shadow server received real requests and processed them, like, and send an actual response. The only difference was the response didn't go out to the user, but the response was later then saved. And the original response that sort of fired the proxy, or proxied the request to the shadow server, also saved its result. And then you just compared the actual rendered page. And that was on live traffic. And I thought that was really clever of basically not affecting live traffic, having a ridiculous granular level, like the actual user's content, diffing that on a character level, and then they basically didn't allow any change whatsoever, even like a space wasn't okay. So that was a pure refactoring, so to speak, from that standpoint, and I think that was a really clean solution to it. No? Oh, okay. Yeah, so like NPM is really fast. My main point, if anything, were to be like, yeah, try to think about, be pragmatic, try to think about, don't do the rewrite if you don't have to, and like, no, there's no silver bullet, because especially when it comes to these kinds of cases, it differs so much.